In this video, we are going to revise the periodic table. And here, we will give you a brief summary of the periodic table, followed by some past exam topical questions. So precisely, we will be dealing with things, we will be dealing with how elements are arranged in order of in order of increasing proton number on the periodic table. We will discuss the groups, the vertical columns in the periodic table. We will also discuss the periods, the horizontal rows in the periodic table. We will also discuss in detail the alkali metals, that is the group 1 metals. The group 1 metals. We will discuss briefly on the transition metals. We will discuss on halogens, the group 7 non-metals or group 7 elements. And finally, we will discuss on the noble gases. Before we continue, I want to thank those of you who have taken your time to subscribe to my channel. And for those of you who haven't subscribed to the channel, please, the only support we want from you is like this video, share it to other learners, and most importantly, subscribe to the channel. Thank you for taking your time to subscribe to my channel. Let's get started. Remember that the periodic table is arranged, the periodic table is a table of elements arranged in order of increasing proton number. Here, we call the groups, as group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 0, or group 8. The modern periodic table will call it group 1, group 2, group 3, 4, 5, 6, 7, 8. We'll call it from group 1, we'll call it 11, group 12, group 13, group 14, group 15, group 16, group 17, and group 18. We will be using these interchangeably. We can use either we can say group 2 or group 12. We may use group 13 or group 3. We may use group 17 or group 7. We may use group 18 or group 8 or group 0. So we will be using it interchangeably. So, what is the periodic table? As I earlier said, the periodic table contains elements It contains elements that are arranged in order of increasing proton number, or what we call the atomic number. In the periodic table, as you see them, as you see it here, the vertical column, I'm talking of group 11, group 12, 11A, group 12A, group 13, group 14, group 15, or what we call group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. These groups, these are the vertical column of elements. The vertical column of the elements, we call them the groups. Then the periods, the horizontal rules. See here, this is period 1, that is hydrogen and helium. This is period 2, that is from lithium to neon. This is period 3 from sodium to argon. All the horizontal rules of elements, we call them the periods, from left to right. It should be noted that within the periods, across period 2, that is from lithium to neon and sodium to argon, across period 2 and 3, there is a gradual change from metal on the left-hand side to non-metals on the right-hand side. You look at it, these are what we call, they are arranged in terms of what we call the blocks. They are arranged in terms of the blocks. Here, like group 1 and group 2, group 1 and group 2, we call them the S block elements. We call them the S block elements. Then in between group 2 and group 3, or what we call group 12A and group 13A, in between group 2 and group 3, because we are more versed with that, there's what we call the D block. This is the D block element from scandium to zinc, in between group 2 and group 3. We call them the D block elements. They have their own characteristics, which are unique to them. Then, from group 13 or from group 3 to group 17, or from group 13 to group 17, or what we call from group 3 to group 7. That is from boron right to fluorine. This group we call these groups of elements, we call them the P block elements. These are the P block elements. Then the last group is what we call group 18 or group 0 or group 8. This group of elements, we call them the inert or the noble gases. They are the inert or the noble gases. Now we are going to start on group 1. We are going to start on group 1. The first column, group 1. Group 1, in other words, we call them the alkali metals. They are the alkali metals. These are the alkali metals. Group 1 elements are known as the alkali metals because they react with water. Alkali metals. They react with water to produce alkaline solution. I said they react with water to produce an alkaline solution. The group 1 elements are very, very reactive. These are the very reactive metals. Group 1 elements, it should also be noted that group 1 elements, the group 1 elements, in order of increasing proton number, are, look at them, we have lithium, hydrogen is not there. We have lithium, we have sodium, we have potassium. and right down to francium. Secondly, you should know that because of their reactivity, because of the reactivity of the group 1 metals, that is lithium, sodium, potassium, and write down. These major ones, lithium, sodium, and potassium, because of their reactivity, they are stored under oil. These elements, they react rapidly with oxygen in the air. They react rapidly with oxygen in the air. With water, with water, excuse me, with water, they react with water to produce alkaline solution, as I earlier said. They react with water to produce alkaline solution and hydrogen gas. For instance, if sodium reacts with water, it will produce sodium hydroxide and hydrogen gas. And the way you see it is that when it is reacting with water, you place it on water, it moves rapidly on water, floating on the water surface, and burning, emitting, um, uh, emitting a very emitting a serious or emitting gases. It emits hydrogen gas as it is reacting with water violently. It is melting at the same time or disappearing at the same time, and very, very explosive. So they react violently with water, producing alkaline solution with hydrogen. Group 1 metals again are also good conductor of electricity and the heat. They are soft and can be cut with a knife. If you observe them, they are very shiny. They are very shiny when cut, but they tarnish rapidly due to reaction with oxygen in the air. Once more, their reaction with water. It should be noted that the metals, they move, when you throw them in water, they move around and float on the surface of the water. The reaction produces heat, which causes the metal to melt as it reacts. In the course of it reacting with water, bubbles of hydrogen gas are given off, and the metal rapidly disappears as it is reacting with water, forming a colorless solution of alkaline metal hydroxide. I said, for instance, if sodium reacts with water or lithium reacts with water, it is lithium hydroxide and hydrogen. If sodium reacts with water, it is sodium hydroxide and hydrogen. If potassium reacts with water, it is potassium hydroxide and hydrogen. Uh, and hydrogen. Maybe let me just, for instance, let me just say here, if we have an equation like this, let me say sodium hydroxide, sodium metal, yes, plus water, plus water. What you will get will be sodium hydroxide, will be a sodium hydroxide, sodium OH, uh, sodium hydroxide, that is aqueous, yeah, which is aqueous plus um, what is wrong with this? Yeah, plus a hydrogen gas that is being released. let me balance our equation. We have, let me say, if I put a 2 sodium here, I will have 2 water here, 4 molecules of water here. I will also have a 2 here, and I will also have another 2 here. 2 hydrogen plus 2 is okay now. So that is how the whole thing, that is how the reaction is. That is how you can get it. Secondly, the reactivity of a group 1 metal will increase down the group. Beginning from lithium right down to francium, the reactivity is increasing. The reason the reactivity is increasing, I will give you, you will have a detail of it at a higher level. At your AS and the A levels, you will have the reason why the reactivity of it is increasing as you go down the group. As I said, the reactivity is increasing down the group. So in terms of reacting with water, you will see that if I should throw sodium on the surface of water, sodium moves around the surface of water faster than lithium. And as it's moving like that, it is disappearing more rapidly. Again, if I should put potassium on the surface of water, potassium moves rapidly and burns into a lilac flame. That's what you will observe. So with this type of thing on group 1, your question, the examiner could ask some trickish question based on the observation that you see when reacting the alkali or the group 1 metals with water. For example, the examiner could say, what would you see in practical chemical what will you see in a practical chemical or physical change when group 1 metal react with water? What will you observe? What will you see or what will you observe when group 1 metal react with water? Here, the examiner does not want you to give the product of the equation that we have written. The examiner wants you to give precisely what you observe in the course of the metal reacting with water. For instance, you could mention that the metal disappears. You could also mention that the metal melts. You could also mention that there is fizzing or bubbles of gas or effervescence. All these are one and the same thing. You could also mention that the metal floats and moves around on the surface of water and disappears. As the metal floats and moves around on the surface of water, it is disappearing or it is melting. You can mention it like that. That is what you are seeing. You can say when the reaction is almost getting to the end. For instance, potassium and other group 1 metals burn into flame. So, however, when the examiner asks such a question, what you should put on your question paper as your answer should be what you are observing, what is happening at that particular moment. That's all about group 1. Let's from group 1, let's move to, this is group 1. This is group 1. Now we are on group 2. Group 2, these are, we call them, group 2, we call them the alkaline earth metals. The alkaline earth metals. That is from beryllium, magnesium, calcium, strontium, barium, and radium. So all these are what we call the alkaline earth metals. So we go to now to group the halogens. We go now to the halogens. The halogens are the group 17 or the group 7. These are the group 17 or the group 7 elements. That is from fluorine, chlorine, bromine, iodine, right down. These are what we call the halogens. The group 7 element or the group 17 elements, as I said, they are in order of increasing proton number. They are arranged in order of increasing proton number. For example, fluorine has 9 protons, chlorine has 17 protons, and bromine has 35 protons as you go down the group. Iodine in that order. So only chlorine, bromine, and iodine we are going to be dealing with. We are going to be dealing with as specified by the syllabus. Bromine, chlorine. We are only going to deal with fluorine, chlorine, bromine, iodine, and astatine. In terms of their reactivity, you will see that the halogens, their reactivity is doing what? Their reactivity is increasing up the group. As you go up the group, their reactivity is increasing with fluorine, which is the most reactive. This is different from what we saw in the alkali metals, that is the group 1 metals. Instead, their reactivity is increasing but downward. As you go down the group, their reactivity is increasing. But for the group 7 or the group 17, or what we call the halogens, reactivity is doing what? Is decreasing down the group. Or it is increasing up the group. And it should also be noted that these elements, they are all known metals. They are all known metals, and they exist as a diatomic. They exist as diatomic molecules. When I say diatomic molecules, I mean a molecule which is, let me say, X, X2. That is a diatomic molecule. They exist as diatomic molecules, like that. So it should be noted that the group 7 elements or the halogens, in their physical properties, or their physical appearance, they move from gas to liquid and to solid. So beginning from chlorine is a gas. This is a pale green gas. Bromine is a liquid. This is a red-brown liquid. Then we go now to iodine. Iodine is a solid, and this is a gray, black solid. So based on their physical appearance, they are moving from the physical appearance. We move from gas, from fluorine, which is a gas, chlorine, which is gas, to bromine, which is a liquid, and to iodine, which is a solid. Regarding their reactivity for the halogens, you should know that the halogens, they once higher up, as I told you, that reactivity is doing what? The reactivity is decreasing down the group. Their reactivity is decreasing down the group. As you are going down the group, reactivity is decreasing. As you go down the group, the reactivity is decreasing. Why do I say that the reactivity is decreasing? In their chemical reaction, the one above, for example, fluorine, fluorine is more reactive than chlorine. Chlorine is more reactive than bromine. Bromine is more reactive than iodine. And in that order, if bromine, if chlorine is reacting with a substance containing bromine, chlorine is going to displace bromine because it is more reactive than bromine. And if bromine is reacting with a substance containing iodine, bromine is going to displace iodine. So chlorine can displace all other elements that are below it on the periodic table. Bromine will displace all other ones that are below it. Iodine will displace all other ones that are below it. But iodine cannot react when in a substance containing chlorine because it is less reactive than chlorine, or a substance containing bromine. It cannot react with it because it is less reactive than bromine. So chlorine displaces bromine and iodine. Bromine displaces iodine but does not displace chlorine because chlorine is more reactive than it. Iodine does not displace chlorine or bromine. So halogens higher up the group can displace those lower down. Alternatively, we can say that reactivity increases up group 7. So that is how the halogens are behaving. Now, we have forgotten, we have not touched the D block. The D block, as I told you, these are a group of elements arranged in order of their increasing proton number from scandium, from scandium here, right from scandium, this is scandium, from scandium here, and to zinc. These are the D block elements. And so what are these D block elements? And why are they called D block elements? So now, in other words, we can call them the transition elements. But when you go at the higher level, not all of them are transition elements or transition metals. Generally, now we call them the D block element or the transition elements. So transition elements are the metals. These are the metals. We call them transition metals or transition elements. So I told you that these elements, they have, or these metals, from scandium to zinc, the first rule, they have some unique properties. They have some unique characteristics that are only identified by them. So it should be noted that these transition metals, they are harder and stronger than even group 1 metals. Because they are harder and stronger than group 1 metals, they have higher densities than the group 1 metals. They also have higher melting point than the group 1 metals. Just as I earlier said, they have some unique characteristics that is found only within them, the transition metals. And some of them, some of these unique characteristics are that these are elements, they form colored compounds. They form colored compounds. They can form colored compounds, or you can say they can form colored ions. Either you say colored compounds or colored ions. For instance, let me say copper 2 sulfate. Copper 2 sulfate crystals are blue. If you look at copper 2 sulfate crystals, they are blue. And potassium manganate 7. Potassium manganate 7 is purple in color. These elements, and their compound, they show catalytic property. They have catalytic property. In other words, they can be used as catalysts. They have catalytic property, or they can be used as catalysts. For instance, we can say finely divided iron is used as a catalyst in Haber's process in the production of ammonia. We can say we can also say vanadium pentoxide. Vanadium pentoxide, or what we say vanadium 5 oxide, is also used as a catalyst in the contact process for the production of sulfuric acid. They also form variable oxidation states. For instance, there is ion 2 ion, a variable oxidation state. That is, they have many oxidation states. For instance, let me say ion. For ion, we can have ion 2 plus and ion 3 plus. For copper 2 again, we can have copper 1 plus and copper 2 plus. Chromium, for chromium, we can have chromium 3 plus and chromium what? Chromium 6. Even manganese. There's manganese 4, there's manganese 2, and there's manganese 7. So these are examples that we say all the transition metals they form variable oxidation state, or they have variable oxidation states. Their oxidation state, they vary. It's not just one oxidation state. There are many of them. Okay. Apart from that, there is one other group of elements that we have not treated. And that group of elements is group 0. Either you call it group 0, or you call it group 8, or you call it group 18, as the modern periodic table calls it. So group 0 elements are known as the noble gases, or the inert gases. They are very, very unreactive. They call them inert gases or the noble gases. We can say the group 0 elements or the inert gases in order of increasing proton number. We can say helium, as you are going down the group. Helium is 2, neon is 10, argon is 18, krypton is 36, xenon is 54, radon is 86. So as you go down the inert group 0, that is noble gases, that is they are arranged in order of increasing proton number. So, as I told you, these group of elements, they are very, very unreactive. They are very, very unreactive because their atoms all have full outer shell of electrons. All the atoms, helium, neon, argon, krypton, xenon, radon, all of them have a full octet of electron. All their valence electrons are full. So because their outermost electron or their valence electrons are full, they have a full octet of electrons, they do not need to share. They do not need to lose or to gain electron to achieve a full outer shell of electron. Once more, because they have a full octet of electron, they do not need to share, they do not need to gain, or they do not need to lose electron to achieve a full octet of electron. For this reason, they are very, very unreactive. Summarizingly, the periodic table is this is a table made of elements arranged in order of increasing proton number. The groups are the columns, and the periods are the rows running from left to right. Elements in the group, all elements in a particular group have the same number of valence electrons. For instance, elements in group 1 shows that all elements in group 1, they have one valence electron. They have only one electron in the outermost shell. Elements in group 2, they have two electrons in their outermost shell. Elements in group 3 or group 13, they have three electrons in the outermost shell. Group 4 or group 14, they have four electrons. Group 15 or group 5, they have five electrons. Group 16 or group 6, they have six electrons in the outermost shell, or they have six valence electrons. Then group 7, group 17, or what we call the halogens, they have 7 electrons in their outermost shell. And group 0 or group 8, they have all 8 electrons in their outermost shell. On the rows, for the rows, that is for the periods, I said this is period 1. The periods will determine the number of shells, the elements they have. For example, this is period 1. That is between hydrogen, that is hydrogen and helium. Period 1 has only one shell. So hydrogen and helium, they have only one shell. Period 2, that is lithium and beryllium, boron, carbon, all these. This is period 2. Period 2, from lithium, beryllium, right to neon, they have only 2 shells. Period 3, that is from sodium, magnesium, right to argon, they have 3 shells. Period 4, that is from potassium, right to krypton, they have 4 shells. In that order, So the number of periods, the period number determines the number of shells that element have, or element in that period they have. The group number determines the number of valence electrons in elements in that group. So we will be starting with our topical past questions. We will be starting with our topical past questions to answer related questions. So now, let's start it from here. okay. Okay. We are starting now with the topical questions. Question number 1. The symbol of the elements of period 3. The symbol of the element of period 3 of the periodic table are shown. That is sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Answer the following questions about these elements. Each element may be used once, more than once, or not at all. Write a symbol of an element which is malleable. Malleable. Malleability exists only within metals. Malleability exists within metals. What is malleability? What is malleability? It should be noted that malleable, that is the ability of a substance to change shape or structure when twisted or when hammered. Again, when we say a substance is malleable, malleable is the ability of a substance to change its shape or its structure when twisted or when hammered, and only metals can do this. So from this group, the metals that are in this group that can do that are the metals in this group that will do that. These are the metals. The metals in this group that can do that are either we say sodium when twisted, um, um, so we can say it is we can say magnesium. They say write the symbol of an element which is malleable, can be twisted. Either magnesium, you take magnesium ribbon, you can turn it, magnesium will be there. Or you can take aluminum, you can use aluminum. It does that. Okay, write the symbol of an element which has only 2 electrons in its outermost shell. I told you that element that has electrons in the outermost shell will determine the group. The number of electrons, the group number will determine the number of electrons in the outermost shell. So, now, 2 electrons in the outermost shell will indicate that there are group 2 elements. And they are all group 2 elements because group 2 indicates that there are 2 elements, there are 2 electrons, sorry, on the outermost shell, or there are 2 valence electrons. So in that case, group 2, the only group 2 element here is magnesium. Okay, write the symbol of an element which forms an oxide, which leads to acid rain. Element which forms oxide, which leads to acid rain. From here, acid rain are caused by elements like sulfur. Elements like sulfur, when sulfur reacts with air, it forms oxygen. When when sulfur reacts with air, it forms sulfur dioxide. Then this sulfur dioxide, when it escapes into the air and reacts with oxygen of the atmosphere, there is sulfur trioxide that is being formed. Sulfur trioxide, when it's being mixed with the rain, it results in sulfuric acid, which now comes down as acid rain and acidifies our lakes, acidifies our farms, acidifies our oceans, and destroy our buildings. So the element in this case is sulfur, S. Write only the symbol. Do not write the name, please. Write the symbol of an element which forms an ion with a 2 charge. An element that forms an ion with a 2 charge. It forms an ion with a 2 charge. Forms an ion with a 2 minus charge. A 2 minus charge. A 2 minus charge, elements of group 6, or what the modern periodic table call group 16, for example, sulfur, oxygen, they will form an ion with a 2 minus charge. And for this, it is sulfur, S. So sulfur will definitely form something like this, a 2 minus. If oxygen was there, it will form something like this. All of them are group 6 or group 16 elements. So E, write down the symbol of an element which is extracted from an ore called bauxite. Bauxite is an ore that contains impure aluminum oxide. So aluminum oxide is extracted from aluminum is extracted from the ore we call bauxite. So the symbol of the element that is extracted from bauxite is aluminum. E is Al. Okay, F. Write the symbol of an element which does not form an oxide. When we're discussing on the periodic table, the only element that does not form an oxide is an element that does not react. It doesn't react, so it cannot form an oxide. So from the periodic table of elements that we just discussed, the elements that do not react are the noble gases. And here, the noble gas here is the argon, which is Ar. So now, our answer is Ar. F is Ar. Then G. Write the symbol of an element which forms an oxide with a macromolecule structure. A macromolecular structure. There are macromolecular structures. When we were dealing with the structures of non-metals, we talked of simple covalent structures. We talked of giant covalent structures. We talked of simple covalent structures to giant covalent structures. And these giant covalent structures are what we call the that are those structures that that have micromolecular structures. And a giant molecular structure, an example of a giant molecular structure that we did discuss the other time was silicon dioxide. That was diamond. So a silicon dioxide, for instance, let me show you a silicon dioxide. This is a very good example of a structure, a giant molecular structure, or what we call a macromolecular structure. This is the structure of a silicon dioxide. It is formed between silicon and oxygen. So now the structure, an element that forms an oxide with a macromolecular structure is Si, silicon, and that is Si. Si, G is Si. So it should be not from our diagram here. You should know that from this diagram, it should be noted that silicon is a covalent silicon dioxide. That is an oxide formed by silicon, is a covalent molecule with 4 oxygen atoms connected to each silicon atom. 4 oxygen atom connected. This is a silicon atom here. We have 1, 2, 3, 4, with 4 oxygen atoms connected to each silicon atom with a tetrahedra. It is a tetrahedral structure. So now let's go to H. Write the symbol of an element which forms an amphoteric oxide. It should be noted that we did not discuss on the periodic table on oxides, elements that form amphoteric oxide. We did not discuss on group 3 elements. So most of the elements that form amphoteric oxides are mostly group 3 elements. And a specific example of this is aluminum. Aluminum is amphoteric. That is, aluminum oxide is amphoteric. The oxide of aluminum will act both as an acid and as a base. That is why we say it is amphoteric. So the element here is Al. H is Al. Now, write the symbol of an element that exists as a diatomic molecule. As we're discussing on the periodic table, I told you a diatomic molecule, only halogens are diatomic. A diatomic, as I told you, halogens exist as diatomic. For instance, a halogen here could be something, let me say, a diatomic is an element like this. So now it will be a covalent bond formed between the 2 atoms of X. An example, let's say an example is chlorine. If chlorine is a diatomic molecule, for that purpose, chlorine will form a covalent bond with the between the 2 atoms. So chlorine, they will share electrons. They will share electrons. So an example of an element that exists as a diatomic molecule, or what? Exists as diatomic molecules. We will have chlorine. As diatomic molecules. We will have a Cl. Oxygen is also an example, but they'll say write the symbol. They think write the symbol of an element which is You can write, oxygen is not here. We cannot write oxygen. Oxygen does not exist as a diatomic. So you cannot write oxygen. So the only one here is chlorine, Cl. We are writing by the symbol. Do not write anything outside what you have been given. Okay, forms a binary compound. Write the symbol of an element. Write the symbol of an element that forms, that is J, that forms a binary compound with hydrogen. That is a strong acid. A binary compound with hydrogen, that is a strong acid. So now, what is a binary compound? A binary compound, that is a compound containing two different elements. A binary compound. A compound is a compound that is a substance formed between atoms of two different elements, two or more. But since it is binary, atoms of two different elements. So a binary compound, this is a compound that contains two different elements. It forms compound with hydrogen. That is a strong acid. The only compound that forms with hydrogen that is a strong acid, I cannot talk of sulfuric acid, because now there are already three elements involved. There are three elements involved, but with hydrogen. So I need only one element that will combine with hydrogen to form a strong acid, and that is chlorine. Cl. Because when chlorine combines with hydrogen, it forms a strong acid, and that strong acid is hydrochloric acid. That is hydrochloric acid. That is hydrochloric acid. Now it moves us to the second part of the question. It moves on to the second part of the question. So now, the diagram below shows part of the periodic table. We have group 1, 2, 3, 4, 5, 6, 7, and group 0. Some of the elements are being given using only the symbols of the elements, shown above. Write down the symbol of an element which is a pale green colored toxic gas. When we're discussing about halogens, group 7, I told you that the halogens, they change state from the gas, which is chlorine, to liquid, which is bromine, and to iodine. I also said that the gases, chlorine is a brown, chlorine is a greenish gas. It's a pale greenish gas. And the bromine was a brown liquid. So they are now telling us the symbol of an element which is a pale green colored toxic gas. So it is Cl, which is chlorine. So our answer here is Cl. Our answer for A is Cl. This is the gas here, is chlorine. This is the gas here, is chlorine. Chlorine is a pale green colored gas. Now, write down the symbol of an element which is stored under oil. When we were discussing on group 1 metals, we said the group 1 metals from lithium, sodium, potassium, all of them are very, very reactive. For that purpose, they are stored under oil. So between all of the group 1, the only group 1 element here among those elements which we did in our review, in the review we did, is lithium. So our answer for B is Li. C. Write down the symbol of an element which has 5 electrons in it. 5 electrons in its outer electron energy shell. I said that the group of elements that will show the group of element determine the number of valence electron. Group 1, they have 1 electron. Group 2, 2 electron. Group 3, 3 electron. Group 4, 4 electron. Group 5, 5 electrons. So now, for 5 electrons, we are going to have P. We are going to have P, which is phosphorus. C is P. Now D. Write down the symbol of an element which is the most reactive group 2 element. The most reactive group 2 element. The most reactive group 2 element. The most reactive group 2 element here, as we said, reactivity will increase, it is increasing down the group. So the most reactive element for in group 2 will be Ca. This group 2 is Ca, calcium. Yeah. Now, it goes to E. Write down the symbol of an element which is the most reactive halogen. We discussed on the halogens and we said that reactivity for metals, for these metals, reactivity is increasing down the group. For metals, reactivity is increasing down the group. But for halogen, reactivity is doing what? Is increasing up the group. As you are moving up the group, reactivity is increasing. So the most reactive halogen will be what? It will not be bromine. Since reactivity is increasing up the group, the most reactive will be chlorine. Cl. E is Cl. Then F. F. Write down the symbol of an element which is the only liquid shown. Write down the symbol of an element which is the only liquid shown. As we said, as I told you when we're discussing on the periodic elements of the periodic table, we are moving from metals. From these are the metals. These are the transition metals. Then to non-metals, and from non-metals we now move now to what? To the inert gases. So on the periodic table, from left to right, we move from metals to non-metals, and to what? And to the inert gases or the noble gases. So within the non-metals, the substance that is liquid. Within the non-metals, The only substance that is liquid is found within the halogens, because in the physical properties of the halogens, as we said, the appearance, we leave from liquid, from gases to liquid. From liquid, we move down to solids. So between the groups, group 7, the only liquid there here is bromine, that is Br. So F is Br. F is Br there. Now, G. Write down the symbol of an element which is a transition element. A transition element. A transition element. When we were discussing the periodic table, I said transition element or transition metals are found between group 2 are located or are found between group 2. They are located or they are found between group 2 and group 3. So between this block here, the D block element here, or what we call this group here, is what we call the transition metals or the transition element. So from all these, that is from scandium, I say from scandium to zinc, they are all transition elements. And the only one that is found here is zinc, Zn. So the only transition metal found here is Zn. So G and finally H. H. Write down the symbol of an element which is a gas. With 2 electrons in its outer shell. An element which is a gas with 2 electrons in its outer shell. The element, okay, it should be remembered that we would have said it is a group 2 element. It is not a group 2 element. Group 2, these are metals, they are not gases. So which other element in this group, in this periodic table, is a gas and has only 2 electrons in its outermost shell? Okay, group 0, they are all gases. But the one that has only 2 electrons, okay, helium. Helium belongs to period 1. And period 1 shows that it has only 1 shell. And the only shell is what? The only shell has 2 electrons. Hydrogen is 1, helium is 2. Helium has 2 electrons. Only 2 electrons. Helium is a noble gas. And this is the element we are looking for. So helium is a gas with 2 electrons in outer shell. So He is the answer. That is it. So thank you very much for listening. Once more, I want to thank those of you who have subscribed to our channel. And for those of you who haven't subscribed, please like this video, subscribe to other fellow learners, and most importantly, subscribe to our channel for more revision lessons.